Well, what a wonderful audience. Thank you so much for coming. So many of us at one time or another will have asked ourselves, what is distinctive about the human mind? What makes us different? And I think a strong candidate is imagination, our capacity to detach ourselves from the here and now, anticipate the future, recollect the past, enter the virtual worlds created by artists and the world revealed by science. So I'm with the anthropologist Robin Dunbar when he writes, what sets us apart is a life in the mind, the ability to imagine. And on that background, you can imagine that my interest was piqued when about 20 years ago, I was handed this referral letter of a patient who had lost the ability to imagine anything. He notes this particularly at night, when he's never been a good sleeper and previously used to imagine things to help himself get to sleep, but now finds he's unable to do so. He can't picture his children or his grandchildren, whereas previously he had been able to. Please see and advise. Now, this was a symptom I thought was very fascinating, one that I'd not come across before in my practice as a neurologist. We're going to come back in a moment to MX and the story of the work that we did with him and the research to which that work subsequently led. But I'm going to introduce you first in a moment to a visualization exercise to get you in the groove. And that will occupy the first part of the talk, and then in the second part, I'll turn from the topic of visualization to the rather broader topic of imagination and its prerequisites, particularly in the brain. So let's start with visualization. Now I'd like you to, either with your eyes open or your eyes closed, whichever you prefer, visualize a rising sun and consider carefully the picture that comes before your mind's eye. Now imagine the sun rising above the horizon into a hazy sky. The sky clears and surrounds the sun with blueness. Some clouds appear. A storm blows up. There are flashes of lightning. And finally, a rainbow appears. Now, this is very rough and ready, but I'd like you to rate the vividness of the images that you formed. And I think we can do this without our eyes closed. I'd like anyone who thinks that their image was perfectly clear and vivid as real seeing or approaching that to put up their hand. Okay, so a few hands are going up, just a few, as I'd expect. Clear and reasonably vivid? Okay, a larger number. Moderately clear and lively? Vague and dim? No image at all, you only know that you're thinking. Okay, excellent. So, a very wide distribution, as I'd expect. The majority are somewhere in the middle, but there were a few people right out at the extremes of this interesting distribution. So this is a capacity which varies quite widely, and we'll explore what that may mean. When do we engage imagery, those of us who have it? So typically when we recollect, so if you imagine last year's holiday, it's quite likely that a visual image will come to mind if you have imagery. If you read a novel, it's likely that a descriptive passage will bring an image to mind. So people often say when they go to see the film of the book that the character wasn't at all as they'd imagined him or her, proving that they'd formed a visual image while reading. Many of us, while we daydream, form visual images. We certainly have very vivid visual imagery, typically when we dream at night. And creative people often describe using imagery in their creative work, for example, Einstein. Imagery has been described as an emotional amplifier. So if you are, for example, craving that bar of chocolate or the next drink, it's quite likely that you will visualize it, and that visualization will then intensify your craving. So it can have an adverse effect on our mental lives, but it's also used often by psychologists in therapy and can, in that way, be psychologically beneficial. It's harnessed in mental practice. So surgeons, for example, often describe using, rehearsing their images, rehearsing their operations with the help of mental imagery and reflecting on their operations, more or less successful, also using visual recollection of what happened at the time. And there's evidence that indeed surgeons can improve their practice in that way. There was some fascinating work now 15 years or so ago by Adrian Owen showing that it's possible to detect the signatures of imagination in the brains of some people who appear to be in a vegetative state. Important work which led to the realization that around 5 to 10% of people in the vegetative state are in fact not. And those who show those signatures of imagery in the brain tend to become more overtly conscious over the following months. Studies using what's called descriptive experience sampling, by which a buzzer goes off in your pocket and you have to report there and then what's passing through your mind, show remarkably that visual imagery is actually the commonest mental content, even more common than sensory awareness of your immediate surroundings. So what is going on in us when we visualize? Well, much of the talk will bear on this, but imagery has been described as weak vision, weak perception. And one very nice illustration of this is to be found in this experiment, which I wish I'd done, but I didn't. If you look at the sun, your pupils constrict, of course. If you imagine looking at the sun, your pupils will constrict. If you imagine looking into a dark room, your pupils will slightly dilate.
You ready? MLS is game on. Dochi? On. Stars on.
Kevin Sullivan, the history maker.
30,000 friends? On. Rivalries on.
Red Bull New York versus New York City.
MLS, this is our soccer. Game on.
She's not like other students, so we're not like other schools. With Fusion Academy's one-to-one instruction, you won't just see a difference in her grades and her passion for learning. You'll see a difference in her.
Let's look into the brain. I'm going to show you quite a number of images of this kind from functional brain imaging. So I better explain the basis of this technique very briefly. It's really, in a way, quite simple, and it relies on the principle that brain is like muscle. So when we exercise a muscle, blood flow to the muscle increases. Similarly, when we use a part of the brain for a particular purpose, for example, to look at faces, blood flow to regions involved in looking at faces increases, and it's possible to visualize this, demonstrate this using a variety of brain imaging techniques, now most commonly functional magnetic resonance imaging. And this is an fMRI study showing you areas of the brain that become particularly active during perception of faces. So if you look at a face, you'll activate your fusiform gyrus on the undersurface of the temporal lobe. That plays a key role in recognizing faces. You'll activate your amygdala, which is involved in reading the emotional tone of the face, and your superior temporal sulcus will tell you something about the expression of the face. If you close your eyes and imagine a face, you activate the same regions, but more weakly. So visualization is a kind of weak echo of perception in this sense. Here's another example, showing you again the fusiform face area, but also the parahippocampal place area, which is a part of the brain that becomes particularly excited when we look at building sites, or the Eiffel Tower, or the Houses of Parliament. If you simply imagine face, place, you can set up just the same kind of oscillation in these areas as you would if you were looking at one and then the other. But of course, when we visualize in an experiment, if you're asked by a psychologist to visualize an apple, you will be making a decision to do so. So as well as activating areas of the brain involved in vision, we activate areas involved in decision-making. These are areas towards the front of the brain, involved really in cognitive control, in deciding what we should do with our minds. And you'll also activate regions of the brain involved in memory, because you have to remember what your spouse's face or the Eiffel Tower looks like. So it's not surprising that visualization activates quite a widespread group of brain regions. This is a fly-through of the brain areas involved in visualization prepared by my colleague Crawford Winlove on the basis of about 20 functional imaging studies. So as you can see, there's a distributed network of regions involved in visualization. Before I come back to MX, I just want to mention 2 points which I might otherwise forget. I'm talking about visualization here, but much the same almost certainly applies to other forms of sensory imagery. So using the mind's ear to hear a song, or the mind's running legs to imagine running for a bus. And one might think that looking and acting, remembering, imagining, activate very different regions of the brain. But in fact, one of the implications of the work I've just been describing is that when we remember, when we imagine, we use regions of the brain which substantially overlap with those that are engaged by looking and acting. Okay, let's return to MX, and I'll allow him to introduce himself.
I found that I first noticed it just a few weeks after I had my angioplasty. Mm-hmm. I noticed at night when I went to bed that I couldn't do what I usually did, which was, before going to sleep, thinking about my family, my children, my grandchildren, and picturing them. They just wouldn't come to mind. And also, I used to have a technique to go to sleep. I couldn't get to sleep, and that was to start at 99 and count backwards. But looking at the numbers, either black on white or white and black, and watch them in my mind's eye and click them off, and I never got down to one. I was asleep by then. So that was about 3 weeks after I'd had the angioplasty.
Mm-hmm. Did you find that all visual imagery had disappeared? So were you able to visualize places which you'd visited, for example?
No, I couldn't visualize anything. I could remember them, but I couldn't visualize them.
Mm-hmm. And you don't think that the inability to visualize has had very much impact on your ability to remember?
As far as I can see, it hasn't had any effect at all.
Mm-hmm.
My memory is as good as it was, mm-hmm. I think.
Even to remember visual details?
Yes, I know that sounds a bit odd. Even to remember visual details, which I can't see, mm-hmm. but I can remember.
Mm-hmm. Mm-hmm. You just know?
I just know, but I can't see them, and I can't explain that.
So MX gave a very consistent account of his experience. He said that when he read a novel, he no longer entered a visual world. He no longer dreamt visually. He continued to dream, but he dreamt in a kind of narrative form. He said that previously, if he'd lost his keys, he'd be able to visualize where he put them. He could no longer do that. We tested him extensively, and we found it very difficult to identify any cognitive deficits at all. And indeed, when we asked him questions which you might have thought would rely on imagery, he was able to answer them. So, for example, which is darker, the green of grass or the green of a pine tree? Now, most of us, when we're answering that question, will summon up the two shades and compare them. MX did fine, but he said he just knew. He didn't rely on an image because there wasn't an image to rely on. So because we found it difficult to identify a correlate for the very convincing change he described in his experience, we eventually resorted to brain imaging. And this is a study in which we asked him to look at famous faces and then to imagine famous faces. When he looked at them, his activity was statistically identical to the activity in a group of matched controls. So he had normal brain activation when he was looking. But when he imagined, the bright colors now are areas of reduced activity, he failed to activate or hypoactivated the areas in the brain, which I showed you a moment ago, including the fusiform face area. So this seemed to be quite a nice neural correlate for the change he described in his experience. He also hyperactivated some areas at the front of the brain that are involved in cognitive effort. So I thought his case was fascinating. It was a neurological symptom I'd not encountered, and we'd identified a change in brain activity which seemed to correlate with the changes in his experience. We wrote a paper about him, and I didn't expect too much more to follow. But as Alexander Fleming said of the discovery of penicillin, sometimes we find what we did not look for. And a rather astute American science journalist, Carl Zimmer, wrote a description of MX's case in Discover, which is the American equivalent of New Scientist, I think. And over the course of the next few years, I was contacted by about 20 people who said, I'm just like MX, but I always have been. I've always realized that I'm a little bit different in this respect. When people are talking about last year's holiday, I can't see anything, they can. So we responded to the contacts from these 20 or so folk by sending them, first of all, a vividness questionnaire. I gave you some of the scenarios which this questionnaire describes there are 16 in total with a score running from 1 to 5. So if you see everything as vividly as if it were really before you, you score 80 over 80. If you see no images, you only think about the scenarios, you score 16. And the people who contacted us, as you would expect, were all down at the low end of this scale. When we came to describe them in a paper, we felt that this phenomenon deserved a name. There were some terms in the neurological literature, but they were very unwieldy ones, like defective revisualization and visual irreminiscence. So I contacted a classicist friend, David Mitchell, who said, well, why don't you borrow Aristotle's term for the mind's eye, phantasia, and tagone on at the end. So the term aphantasia was born over a cup of tea in a Bloomsbury cafe, and the term hyperphantasia sort of popped up naturally as the converse. So what did we learn from these 20 or so folk who'd initially contacted us? As well as sending them the vividness questionnaire, we asked them some common sense questions. They told a reasonably consistent story, so they tended to notice this variation in their experience in early adult life, often when they were reminiscing with friends or family about a holiday, but sometimes in a class in which they were given a meditation exercise. Typically, they said that the realization was that what people had been talking about all these years was meant literally, not metaphorically. So when people talked about seeing in the mind's eye, most people really were seeing something, but they didn't. It didn't generally have a big emotional impact on them. They found it curious rather than devastating. Interestingly, half of them said, you know, it's not just my mind's eye. I don't hear anything when I recollect music and feel the touch of velvet. I don't know quite what that would be like. But the majority dreamt visually. So there was a fascinating dissociation between the absence of imagery in wakefulness, the presence of imagery in the majority in their nocturnal dreams. 2/3 of them said they had a rather thin autobiographical memory. They realized that they recollected less about their personal past than most of their friends and family. And most of them described verbal, analytical, and mathematical strengths, but then they were all readers of Discover magazine, so a rather biased sample. One of my psychologist colleagues suggested that we ask this question. Sitting in your chair, can you count the number of windows in your flat or your house in your mind? And the majority of them could do this, but they described rather interesting approaches to doing so. It didn't involve imagery. So 5 windows, I remember them, but I don't see them. My thought is intentional and object-orientated, and I consider the windows to be in mind. I sort of fly through the house and inspect every room. If the idea of a window is present, it's definitely not an image. It's more like understanding the idea of a window being there. I know it's there. So words are powerful things, and I should say that the press and the internet have been a huge benefit to this line of research. And the press liked the term aphantasia, it caught on. And so over the course of the next few years, our 20 research participants turned into now approaching about 20,000. And I'll give you a sort of impressionistic tour through what we've learned over the years since then. So first of all, I was struck by the degree of gratitude that many people expressed. The greatest mystery of my life explained. It was the first time that I'd heard the word, but I cried when I read it. I've always wondered what was wrong with my brain because I can't visualize or meditate the way other people can. We think that about 4% of people of the world's population lack a mind's eye. So there was quite a large number of people who were glad to have a term to describe this variation in their experience and glad that some attention was being paid to it. Then we noticed a number of associations, and I should say I don't think aphantasia is one thing. I think it's a feature of experience which can occur in a number of different contexts. So it may well be that there are subgroups which we have yet really to tease out. But the first association was with difficulty in face recognition, which in its clinical form is called prosopagnosia. So quite a lot of people with aphantasia said, I have real problems recognizing folk. Most of them not to a clinical degree. And when we asked them, indeed, there was an excess of reports of face recognition difficulty among people with aphantasia compared to people with hyperphantasia or people with average imagery. And that finding's been borne out now by some more objective studies looking objectively at face recognition. As we expected from an initial 20, many reported some, I should say, amnesia is autobiographical amnesia. Many people reported some degree of difficulty with autobiographical memory. So you see around over 30% of people with aphantasia were describing bad autobiographical memory. And this we've looked at further, and it turns out to be quite measurable. So using a technique which extracts as many details as possible from people when they're recollecting their past, you'll see that the number of details supplied by people with aphantasia is lower than that supplied by people with average imagery, lower than that supplied by people with hyperphantasia.
Atera is the IT painkiller. Remote monitoring and management, remote access, help desk and ticketing, smart automations, patching, software deployment, scripting. And the amazing thing is that it does all this while still being easy to use. It's magical. Just this clean, intuitive UI where everything is where it's supposed to be and does what it's meant to do. Sorry, I get emotional. Not to mention, with predictive alerts, you solve real IT issues before they become IT problems.
I'm sorry, I can't hear you over the sound of how awesome I am at fixing your computer.
And with advanced reporting and analytics, management can finally understand why I'm the real MVP. Also, per technician instead of per device pricing, that saves us 50% of our IT costs and makes me the new company hero.
Minds show up. Real heroes wear headsets. And you be...
Now, maybe you're not buying this, and that's fine, because you don't have to buy anything. You can try it out right now for free. Set up as a breeze. Just hit the link and try the thing. It's glorious. Atera, it's what IT ought to be.
Accept cookies. Cookies accepted.
If you have a 700 plus credit score, you qualify for Chase's new program where you could access up to $150,000 of capital for free at 0% interest rates to fund any business or investment that you want, all in the next 30 days. Chase's new program allows you to access up to $150,000 of free capital for your businesses and investments without needing any tax returns, bank statements, or pay stubs, and it doesn't require an upfront payment either. If that sounds interesting to you, I create a full case study analysis on this new program that Chase is offering and how not only you can access up to $150,000 for free from Chase, but how you can do this with many other banks as well, so you could fund your businesses and investments and create financial and time freedom. Just click the link on this video and I'll show you exactly how. My name is Andrew Mbesi, and in 2023 alone, I helped over 2,000 people access over $60 million from the banks. That way they could fund their businesses and investments. All of this was done without having to pay the banks a single penny or show any income documentation. And all of that money came at 0% interest rates. Despite all the craziness you see in the economy right now, with inflation rates rising, interest rates rising, and lenders tightening up, I was still able to help thousands of normal everyday people secure the funding they needed from the banks for their businesses and investments. That way they had the power to build the income that would give them the financial freedom and time to do whatever they pleased, whether it was earning income from anywhere in the world or even spending more quality time with family. And what's even better, to access this kind of funding for businesses and investments, it does not take a lot of time, often less than 3 hours. You don't have to be tech savvy, and the bank charges you nothing. Better yet, using the bank's money means that you don't have to risk a single dollar of your own savings either. The bank is begging to give you money, and if you have a 700 plus credit score to qualify, you probably get offers in the mail all the time from the bank to apply for all these lending products. So today, I'm inviting you to a case study I put together for you to show you how you can access free funding from the banks at 0% interest rates. That way you could fund your businesses, investments, and passive income streams to start living the life that you deserve and grow your income. Just click anywhere on this video and you'll be taken to the next page where I break all of this down for you. And look, if you're still with me, no, this isn't baloney, this isn't fake. If you don't believe me, go see for yourself that these banks do in fact offer 0% interest funding. It's actually everywhere on their websites. You could even investigate my YouTube channels, my social medias to see that I'm actually a real person that does exactly what I promise. which is helping people like you access 0% interest funding to fund any business, investment, or passive income stream that you want, so you can start living the life of your dreams today. And plus, I've already helped over 2,000 people access over $60 million. So click on the link now, take a look for yourself, take advantage of this opportunity to get 0% interest funding for your businesses and investments before it's too late, and I'll see you on the inside.
A subgroup of folk reported that they told us that they were autistic, and this was not a huge surprise, given that autism is classically associated with a deficit in imagination, and this again has been studied a little more formally by one of our previous students who did a PhD at Sussex, Carla Dance, who found an increase in autistic traits among folk with aphantasia. Another curious detail, which many people with aphantasia reported, was that they just didn't enjoy reading descriptive prose. Didn't like Dickens much. And I guess this makes sense. So try this out. The figures in this boat were those of a strong man with ragged grizzled hair and a sun-browned face, and a dark girl of 19 or 20, sufficiently likened to be recognizable as his daughter. The girl rowed, pulling a pair of sculls very easily. Many of us reading a passage like that have just sort of the beginnings of an image forming in our consciousness, but not if you're aphantasic. And this gave rise to a really lovely experimental study by an imagery researcher, Joel Pearson, in Sydney. So in this study, people with aphantasia and people with imagery were read really scary stories. And I must say, I've read them and they do make your flesh creep. And if you have imagery, you sweat, essentially. There's a rise in your skin conductance because you are sweating. Not so if you have aphantasia. And it's not that people with aphantasia can't generate this emotional response, because if you show scary pictures, they sweat. So it seems that imagery mediates between the verbal description and the gut response, if you like. Quite a number of people with aphantasia said that they had first-degree relatives who were similarly affected. And in fact, one of the first people to get in touch after we coined the term was Craig Venter, who you may know of. He was the first person to decode the human genome in the States. And he said that he'd always attributed his scientific prowess to the fact that his mind isn't cluttered with images. And we find that if you have aphantasia, then there's a roughly 10-fold increase in the chance that a first-degree relative will have it above the risk the rate one would expect otherwise. So we're hoping to track down some imagery genes with the help of biobanks. The great majority of people who got in touch describe a lifelong phenomenon, a lifelong absence of imagery. But a very much smaller number describe what you could call acquired aphantasia. So they have imagery and they lose it, like MX, our original patient. Here is somebody in this category, and the reason in this case is not hard to find. This was an interesting story. The owner of this scan woke up in the Czech Republic one night, and I'm not quite sure how, but realized she had become aphantasic suddenly. I think she must be one of those people who uses imagery to get herself to sleep. Anyhow, she realized that she could no longer visualize. She Googled absence of imagery, found aphantasia, drove herself to a local hospital, said, I'm acutely aphantasic. Tell me why. And they took it seriously. She was scanned, and she, in fact, had a small, deep, acute stroke in a part of the brain that is plausibly linked to imagery. So it can be caused by stroke, head injury, meningitis, typical forms of brain imagery, but it also occurs for psychological reasons. And in a commentary on our original paper, these authors suggested that perhaps some of these cases were psychogenic. And this man, Cotard, in France in the 1880s, described people with a delusion which now bears his name, Cotard's delusion, the belief that you no longer exist, that you've died. It's a remarkable self-contradictory delusion, and he suggested that part of the explanation for this might be that people with the delusion had lost their mental vision. So he suspected a link, in some cases, between psychosis and the loss of imagery. And there is evidence that depression and depersonalization can affect imagery. And I'm now just beginning to see people who I think imagine that they can't imagine. They have a suggestible form of aphantasia. So I rather like the fact that this change in experience has both straightforward neurological causes and psychological or psychiatric causes, because I believe that neurology and psychiatry are really one subject, and I very much look forward to studying these cases further. We asked people about their occupations, not particularly expecting to find anything, but it turns out that aphantasia nudges you in the direction of STEM, essentially. You're a little bit more likely to be working in the sciences or in maths or in IT, whereas very vivid imagery nudges you in the direction of a creative profession. But we had a nice surprise here. It's always good when your conclusions are challenged, because quite a large number of aphantasic artists got in touch. People who said that actually their interest in the visual world was, if anything, intensified by the fact that they couldn't visualize. Because if you can't visualize and you love the visual world, one solution is to make images of it. So this is work by aphantasic artists. And this is from Little Mermaid. The main artist, Glenn Keane, involved in making these drawings, to the great surprise of his boss, turns out to have no imagery. He says he has no visual preconception of what he's going to draw. He often does quite a lot of scribbling at the beginning and then rubs out the scribbles, and the forms sort of take shape as he works. I mentioned earlier that many of our initial 20 participants could dream, even though they couldn't summon imagery during wakefulness. And this turns out to be true in a much larger sample of 2,000 people with aphantasia. So the majority of people with aphantasia have visual imagery in dreams. Some don't. Some describe dreaming in other interesting ways. But nevertheless, it's striking that there is this dissociation between wakeful imagery and dreaming imagery. And many people find this a bit puzzling and maybe slightly fishy, but I think neurologically it's not so mysterious, because the brain is in a very different state in dreaming to wakefulness. So this is in fact the rat brain, but you see that during wakefulness, a whole number of neurotransmitter systems are working full tilt to keep you alert. In slow wave sleep, these all fall quiet. And in REM sleep, you have a very different situation. Acetylcholine is predominant in the brain. So neurochemically, the dreaming brain is in a very different state to the wakeful brain. And we also know that regional brain activation differs in the dreaming brain. So in the dreaming brain, you tend to switch off regions that are involved in cool logic, like the prefrontal cortex, and you strongly switch on areas which are involved in memory and emotion, linked to the hippocampus, the amygdala. So I think one simple way of caricaturing this is that deliberate imagery is top-down. You make a decision to visualize and you kind of drive the visual system from above, whereas the imagery that we experience in dreams is generated bottom-up. So there is I think, a plausible explanation for this dissociation between dreaming and wakeful imagery. And then I mentioned that the majority of people with aphantasia seemed to have thin or absent imagery in all senses, not just one. So Oliver Sacks got in touch after we coined the term. His aphantasia particularly affected imagery. He didn't have visual imagery, but he had a reasonably active mind's ear, whereas Blake Ross, who was the co-founder of Firefox Mozilla, who wrote a very feisty Facebook post about his realization that he was aphantasic, describes aphantasia in all sensory modalities. And here's some work showing that indeed the majority of people with aphantasia report thin or absent imagery across the board. Spatial imagery may be an exception. Remember those descriptions given by people with aphantasia of counting the windows in their flat or apartment? This is a kind of rather bodiless form of imagery, very, very abstract and schematic, but that seems to be preserved, and it might even be enhanced in people with aphantasia. What about hyperphantasia? I've said very little because we know less about it. We've studied it less, but there seems to be an association between hyperphantasia and synesthesia. That's the phenomenon whereby, for example, the word Tuesday is always blue, or the letters of the alphabet have distinctive colors. So you may say this seems to be a very complex subject with a wide variety of associations, but perhaps this isn't, perhaps this isn't too surprising. It's not running for us, is it? Okay, don't worry. I was just going to show you again the video I showed you earlier, making the point that, that a wide distributed network of brain regions is involved in imagery. Where you have a wide distributed network, it's not surprising that it could be perturbed in more than one way. So I think subtypes of aphantasia are to be expected, really. What is the underlying basis in the brain? We don't know yet, though a number of brain imaging studies are coming through the works. This was our initial study on the subject, which had an intuitively appealing finding that in the resting brain, if you scan people at rest, in those with vivid imagery, you find stronger connections between areas at the front of the brain, which are essentially involved in thinking and decision-making, and visual areas at the back of the brain than you do in people with aphantasia. So this might suggest a mechanism by which thought might translate more naturally into imagery in people with hyperphantasia than in people with aphantasia. So this work has attracted much more public interest than I'd have expected. That's the altmetric score, which is a way of measuring public interest generated by scientific papers. Why should this be? Well, I think it's because we're fascinated by what goes on in one another's minds. If you have imagery, it's interesting to discover that a fair number of people don't. If you lack it, it's nice to have some attention paid to this variation in your experience. I think there are a couple of general conclusions one can draw. The first is that Aristotle was wrong when he wrote in De Anima that the mind never thinks without a phantasm. It seems that there are other ways of thinking than through imagery. A variety of forms of symbolic representation, for example, are available. Some people describe imageless thought. And it seems that visualization is distinct from imagination. It's possible to be aphantasic and yet highly imaginative and creative. What's the underlying dimension that the distinction between aphantasia and hyperphantasia relates to? I'm not altogether sure yet. I don't think it's a straightforward visual-verbal distinction, but it does seem that aphantasia nudges people in the direction of more abstract, more systematic, more semantic ways of thinking, whereas hyperphantasia nudges people in the direction of more experiential, narrative, episodic ways of thinking. This is perhaps the distinction between a scientist and a novelist. This work has, of course, relied on a large team. It started in Edinburgh, moved to Exeter, and recently back to Edinburgh. A great number of students have helped. It was difficult answering 20,000 emails, so it's been very helpful having a team of student assistants. And I'd like particularly to mention Alan Cowie, my tutor many years ago who interested me in the neurology of vision, and Belanger, who's our current postdoc, just embarked on a new wave of work on this subject. So that's visualization, which is one example of what's been called reproductive imagination, our ability to represent things in their absence. And that sense of imagination echoes the etymology of imagination, in fact. So aim is apparently an Indo-European root, which has been around for about 6,000 years or so, and which means to pair or twin or imitate. And it's the etymological root of imagination and imitation and mimesis. But now I'd like to shift from what's been called the reproductive imagination to the productive imagination. So our ability to create things which are both new and useful, to generate effective surprise, to be creative. And I'm going to identify some cultural and neural prerequisites for imagination using this rather playful mnemonic, SKIDS, which stands for skill, detachment, and spontaneity. So, skill first. Skills are habits of body and mind that allow us to do difficult things efficiently on the basis of past practice. And they depend within the brain on what has been called neural plasticity. So let me take a little detour to introduce you to the concept of plasticity. Here is a nerve cell, a neuron from the brain, as depicted by the father or grandfather of neuroscience, Santiago Ramon y Cajal, about 150 years ago. He was a very passionate scientist, and when he first began to look at images of this kind, picked out by the Golgi stain, we still don't know why this stain highlights individual neurons in the brain. He said, dumbfounded, I could not take my eye from the microscope. Now, these neurons are essentially autonomous agents. You could tease one from the brain and onto a petri dish, and it could lead its own independent life. And Cajal gave a pretty good description of them. Here is an image of a neuron from work published within the last year. So he was quite an accurate microscopist. And these are two individual neurons from the brain, but we in fact have around 86,000 million neurons within our brains. As you will know, as many of you will know, these are electrically active, so they're constantly discharging small pulses of electricity. They're doing so rhythmically, and their discharge rate is influenced by the cells which connect with them, which can excite them or inhibit them, cause them to discharge these pulses of current faster or more slowly. And each neuron, in turn, influences the many thousands of other neurons with which it makes contact, inhibiting them or exciting them. So they're electrical beasts, but at the points of contact between neurons, the signal that's transmitted is not electrical, but chemical. And the points of contact are called synapses. That was the term coined by the British physiologist Sherrington in the 19th century. Cajal, in his more passionate way, called them besos protoplasmikos, protoplasmic kisses. Here are little packets of neurotransmitter awaiting release across the synaptic cleft. And this region, the synapse, is the key to plasticity. Because people working with simple nervous systems like Eric Kandel, who studied the sea slug, aplysia, winning the Nobel Prize for his work, showed that simple forms of learning in aplysia depend on strengthening or weakening of synapses. They can also proliferate, grow, retract, die. Aplysia, the sea slug, has about 20,000 neurons. We have about 86 billion to play with. Our neurons are organized into intricate networks. This is a rather beautiful image, again published within the last year, of neurons, excitatory neurons in the human cortex. So the skills which we're able to acquire with the help of this vast number of neurons are extraordinarily rich. Synapses are everywhere in the brain, and so memory is everywhere in the brain, but it gets subdivided by psychologists into a number of subtypes. Short-term memories, ones which you hold on to only while you're using them. Long-term memories for individual events or for facts. And then memories which you may or may not be able to talk about, but which you prove you have by doing something. So whether you're riding a bike or learning some of the vast store of facts, which is represented in each of our brains, or learning about an individual event, you will be modifying the strength of large numbers of synapses within your brain, making use of our plasticity. So that's the intrapersonal story of skill. What about the extrapersonal story? Well, we educate our children over really rather a long period. This is their opportunity to acquire skills, and their capacity to do so depends on our ability to mind share. We are extraordinarily accomplished mind sharers. And I'm going to share with you now a slightly intimate video. I'll explain why in a moment.
Whatever you do it for less at Harbor Freight.
Are you 50 or older? Well, this news is for you. The CDC now recommends you get vaccinated against pneumococcal pneumonia. Why? If you're 50 or older, even if you're healthy, you're 6 times more likely to be hospitalized. So schedule at vaxassist.com.
So, I show this, it's special to me, but it's not special at all. This is typical. It's absolutely normal for 8-week-old babies, that's an 8-week-old baby, to have conversations with their mother usually, but with their parent. It's the foundation of mind sharing, and I think it's quite remarkable. I don't think it happens in any other species, though I might stand to be corrected. That very intense dyadic exchange over the course of the first year of life becomes triadic. So mother and baby begin to direct their attention on objects in the world. And at around the age of 9 months to a year, the baby begins to point and then to use gestures and words to represent, creating an infinity of possibilities. And by the age of 4 or 5, children are beginning to represent others' mental states. So Jack is having a thought, and Jill is beginning to suspect that Jack is having that thought, and Jack is beginning to wonder whether Jill is having the thought that Jack may be having that thought. We engage in thinking of this kind all the time, typically up to about 5 levels of embedding, though people like novelists go up to 7 levels. And when we engage in this kind of thinking, which is called mentalizing, which engages our theory of mind, we use a particular set of brain regions, which we're going to come across again in a moment, including areas on the inner surface of the frontal and parietal lobes. So we are very accomplished mind sharers, and this mind sharing has a fascinating developmental history. There's another interesting neurological story to tell along these lines, and this concerns mirror neurons. So these are cells which become active both when we perform an action and when we watch somebody else performing that action. So they mediate between perception and action, and they allow us, in a sense, to share a common space of action. So when I see you act, I, in a sense, inhabit your action. When you see me act, vice versa. These are cells in the frontal and parietal lobes. I think that our capacity to mind share starts earlier and goes deeper than language and is actually the prerequisite for language, but there's no doubt that language is very useful for exchanging information. And there is, as with most of our activities, there's both a biological and a cultural story to tell about language. So we've known since the 19th century that the literal meaning of language is processed mainly in the left hemisphere, and that areas at the front of the left hemisphere are involved in sequencing fluent speech, that areas towards the back of the hemisphere in the superior temporal lobe are involved in making sense of speech, that these areas are linked, and we now appreciate that they belong to a network. And in fact, whenever you speak or listen, you'll be engaging all these areas involved in the control of output, analyzing meaning, analyzing speech sounds. Our capacity to mind share, to imitate, to use language, these are all crucial in the acquisition of skills. But there wouldn't be much point in having these capacities unless we had some time in which to learn. And indeed, the structure of our lives has changed since, or in comparison with apes. So we have a period of early childhood, which doesn't exist in the life structure of apes, and a prolonged period of adolescence before we reach maturity. So a very long time indeed to acquire the complex skills which we need to navigate our lives. So I should have said at the outset that the reason I've told you about skills is that I don't think any creative achievement occurs without a very high degree of skill. So I think skill is one prerequisite for creative achievement. I said right at the outset that our ability to detach ourselves from the here and now was one way of thinking about imagination. So what is it that allows us to detach ourselves in this way? Well, we have a capacity for cognitive control, which psychologists call executive function, the ability to organize our thought and behavior, which depends on our very large frontal lobes. This allows us to disengage and work on things which are not immediately critical, but which will be useful if we work on them in the long run. And it's worth pointing out, I think, that because people often talk of the frontal lobes as if they were the sole seat of cognitive control or executive function, that in fact the frontal lobes reach down deep into the brain and interact with the basal ganglia, which are large chunks of brain, play a key role, for example, in Parkinson's disease, and there are also important connections between the frontal lobes and the cerebellum at the back of the brain, a brain region that's traditionally thought to be involved in the control of balance, but which clearly also coordinates thought and feeling. And then a second source of our detachment is our capacity to use symbols. So our brains contain representations of the world, and we represent those representations with the help of symbolic technologies, which include language, but also number and other forms of symbolic notation. The third prerequisite is spontaneity. And I'm going to make spontaneity, the S, my final S, do quite a bit of work. And I guess this is the new news in this talk, because I'm going to be talking about discoveries made over the last 20 years or so in neuroscience, which I think illuminate our capacity to create spontaneously. The process of creation has traditionally been divided into 4 stages: preparation, incubation, illumination, and verification. And the discoveries I'm going to be talking about speak to illumination. And I'll introduce this by way of a story which I like. It may be too familiar, but certainly it's one I only got to grips with recently. And it's the story of Frankenstein's monster and his creator. So Mary Shelley, many of you may know, eloped scandalously with Percy, and they found their way after eloping to the shores of Lake Geneva, where they had a rather bad time, because it was the year without summer. Mount Tambora had exploded, and the world was covered with cloud. There was very little sunlight, not much to do. So Mary and Percy, who were spending time with Lord Byron, decided that they'd tell each other stories. And after a while, they decided they better start making them up. And Mary took this duty very seriously, but she found it tough. I felt that blank incapability of invention, which is the greatest misery of authorship, when dull nothing replies to our anxious invocations. Have you thought of a story? I was asked each morning, and each morning I was forced to reply with a mortifying negative. Well, one evening she sat listening to Percy and Lord Byron talking about the principle of life and whether there could be artificial life. And that night, when I placed my head on the pillow, I did not sleep, nor could I be said to think. My imagination, unbidden, possessed and guided me, gifting the successive images that arose in my mind with a vividness far beyond the usual bounds of reverie. Lovely phrase. Well, you might say she was a romantic, shucked up with romantics. This was the kind of thing they'd claim that they did. But descriptions of this kind are actually the rule rather than the exception among creative people. So here's a sober 19th century mathematician describing solutions to problems coming to him with brevity, suddenness, and complete certainty. Goethe, the songs made me, not I them. Thackeray, the occult power that moves the pen. Carroll, Lewis Carroll of Alice in Wonderland, nearly every word of the dialogue came of itself. Yuri Faludi, a poet, who said he'd sometimes be disturbed in the night by a voice which told him that it was time to write. He said, that voice has my number, but I don't have his. In fact, I had so many examples in my book that the editors insisted that I remove 2/3 of them. So how to explain this apparently spontaneous process of illumination or inspiration? Well, I've explained that we have 86 billion of these, that they're organized into intricate networks, they're connected by connectomic highways in the brain, and all of these things are abundantly alive. And over the last 20 years or so, one really interesting line of neuroscience research has been into what are called resting state networks in the brain. So the brain never stops working. And if you lie in a scanner and chill, the networks of your brain will continue to tick over. And it's possible to, using magnetic resonance imaging, to identify networks involved in vision or in controlling movement or in hearing. But some other really interesting and unexpected networks have popped out, including this one, which is called the default mode network. So this is the set of regions which is most active in the resting brain. What does it do? Well, it's involved in recollecting the past, anticipating the future, thinking about ourselves and others, similar regions to those I showed you in the slide a moment ago, and making moral decisions. So this, if you like, is a kind of daydreaming network, clearly relevant to imagination. If you were lying in the scanner chilling, your default mode network would be active. If you were then interrupted by an annoying experimenter who said, I'd like you now to tell me as many words beginning with the letter P as you can think of in the next minute, you'd switch these areas off and your central executive network would get to work. If the experiment was then interrupted because someone let you know that your son had fallen off his bike and broken your arm, the salience network would become active. These are three networks which were, in some senses, suspected before the recent work on resting state networks, but this has demonstrated them much more clearly and vividly than before, and I think they're very relevant to imagination and creativity. Here's another example. Replay. This was discovered in animals. If rats learn their way around a maze, you can show that cells within the hippocampus become active as they move from point to point within the maze. So that's interesting in itself. The hippocampus contains a representation of space. But then when the rat is resting or sleeping, those same cells become active in the same sequence. So the rat replays its experience. And it's been established that this replay plays a key role in consolidating memories within the brain. The same happens in us. As you rest or as you sleep tonight, your brain will be rehearsing the more interesting, salient experiences that you had during the day, and that will influence your memory for them subsequently. Whether replay ever becomes conscious is a really interesting question, but it may do. Many of us have those odd mind pops when a place suddenly comes into mind or a person comes into mind, and there's no obvious reason for it. Perhaps we're getting a little glimpse of replay. Dreams provide another, perhaps more obvious example. So when you're waking, I think we all are, most of us are, the metabolic activity in your brain is high. When you fall asleep tonight, about an hour in, the metabolic activity won't cease, but it'll drop by about 20%. But then 4 or 5 times during the night, you'll rise into this fascinating paradoxical state, rapid eye movement sleep, in which we have dreams, and we compose remarkable narratives without any conscious intent. And one final example of the brain's of the spontaneous activity within the brain, which may, I think, be very relevant to moments of illumination and insight in this case. This is a study precisely of insight, which used something called the remote associates task. So, what links pine, tree, and source? Can anyone shout out? Pine, tree, source. Thank you, apple. That was possibly you knew, or maybe that was an insightful solution. But a few people will just get the answer. It'll come to them in a moment. Most people, it doesn't come. You kind of search around and eventually you get there. So this study compared exactly those two things, the insightful solutions and the painstaking solutions, and showed that if you have an insightful solution, there's a little burst of high-frequency activity coming from your right temporal lobe, which is interestingly a region where words are represented, but relatively loosely in a way that might promote the ability to spot remote associations. Things that we do spontaneously, we generally do because we want to. There's some reward. And I think arguably, creative activity is immensely rewarding for all of us because our lives are imbued by culture, and culture is the product of imaginative activity, and it's actually what has allowed us to survive as a species. So it's rewarding. Imaginative work, creative work is rewarding in that very basic sense. But there are also some personal rewards. So here is E.O. Wilson, the American entomologist, describing the kick that we get from indulging curiosity. Exploring. There's no drug more addictive than setting foot on virgin soil. And many of us will have, from some part of our lives, an experience of flow, which is again associated with creative activity. So this is that self-transcendence which you can experience when you are involved in a task which matches your talents, in which you're fully engaged, which is intrinsically rewarding and which allows you to forget yourself and the passing of time. Nicely, I think, described by Einstein. This is what the painter does and the poet, the speculative philosopher, the natural scientist, each in his own way. Into this simplified and lucid image of the world and its formation, he places the center of gravity of his emotional life in order to attain the peace and serenity that he cannot find within the narrow confines of swelling personal experience. It's certainly like that for me. A final example. This, I think, is my favorite study from the last 20 years or so of functional imaging work in this context of creativity and imagination. So I'm going to ask for a little bit of audience participation again. Can you put up your hand if you sometimes experience shivers down the spine, or chills, as Americans call them, in response to music, or an interesting idea, or... Okay, great. So I would expect the majority of this audience to report them. They, in fact, occur only apparently in about half the population. And this study investigated them. So the backstory is that Anne Blood was a rock drummer, the first author, and Robert Zatorri was an organist. And they got talking, and they realized that they both got a lot of pleasure from music, but from very different kinds of music. And they wondered if there was some sort of common currency in the brain. So they asked professional musicians to choose passages of music that reliably gave them shivers. And it turns out that if it does it once, it's likely to keep on doing it. But different people get their shivers from different passages. So you can do a very nicely controlled experiment in which you play someone the passages which give him his shivers or her shivers, and then you play the passages which give other people shivers, but not him or her, and you see what's different in the brain. And the shivery passages essentially engage the reward network in the brain, the same network that is engaged by chocolate or sex, including some areas, very deep, very primitive areas deep in the brain, areas involved in addiction, areas involved in interoception, the ability to monitor our gut feelings. So those areas which are generally activated by reward are switched on when you have your shiver or your chill, and some other areas are switched off, including, for example, the amygdala, which is associated with fear and anger. Okay, so that's more or less the end of the journey. I thought I should suggest some general conclusions at the close. So, first of all, in the first part of the talk, I introduced you to an interesting invisible difference between us. We vary greatly in the vividness with which we visualize, and those differences seem to have some interesting associations, psychological associations more widely. Secondly, I think we're all imaginative. It really is our human stock in trade. We're imaginative in the sense that our immediate experience is a kind of creative act. Perception itself depends on a huge stock of hard-won knowledge and on ceaseless activity in the brain, consuming oxygen, consuming glucose. So I very much agree with the romantic poet and critic Coleridge, who wrote a long time ago, "The primary imagination I hold to be the living power and prime agent of all human perception, and a repetition in the finite mind of the eternal act of creation in the infinite I am. The secondary, that's what we'd call creative imagination, I consider as an echo of the former. It dissolves, diffuses, dissipates in order to recreate. It struggles to idealize and unify. It is essentially vital." Then I think we're deeply cultural creatures. And what I mean by this is that we are biologically cultural. I'll explain what I mean. Over the last 3 million years of human evolution, our brains have tripled in size. There hasn't been much change in body size, so this is all gain in useful, thinking, creative brain. Now, what was happening during those 3 million years? Well, our ancestors began making tools about 3 million years ago, a little over 3 million years ago. They conquered fire maybe 900,000 years ago and began cooking about 600,000 years ago. So culture got going during the period that our brain was tripling in size. And it was almost certainly one of the drivers of brain evolution. So by the time by the time we experienced the extraordinary cultural flowering that occurred 30 to 40,000 years ago when our ancestors began to make cave art, we were already thoroughly cultural creatures. We evolved in a cultural niche, and just as birds are adapted to the air and fish are adapted to the sea, we humans are adapted to culture. And finally, I hope I've persuaded you that the brain is a conducive home to imagination. It didn't really seem so when I embarked on training in neurology 40 years ago, but I think the discoveries I've described have made it seem a much more conducive home. It's ceaselessly active. It reverberates, rehearsing recent experiences, consolidating memories. It generates insight. It's capable of ecstasy. Here's one of my favorite pictures by Chagall. I hope to have persuaded you that, as Picasso said, everything we can imagine is real.
Be courageous, be bold, take the move and just do it.
Light, sweet, made with watermelon seed flour? Simple Mills.